like a web services kind of a model, as opposed to today, like Steve talked about, provisioning of the services by an operator or a specific vendor at that point. So that will move away. And I think the third piece is the IoT, which is now Internet of Things is, or Internet of Everything, is all about where you have a reach for that device or capability provisioning. I think the 5G network becomes a much more ubiquitous across the world. So a company which is doing business in, let's say, Europe should be able to do business in US or other parts of the world much more easily. So I think that's what I think.
Absolutely. So I think there's a question from the audience. Yes, please.
Prakash from FutureWide. Question to all of you is, we have seen in the earlier generation that hardware used to drive everything, so the standardization was critical. But these days, software is driving it, and even if we talk about a 4.5G in terms of NFV and open platform for NFV, that's like, that doesn't follow the standard. It's what software offers you, here what it is, take it or leave it. And trying to find the gaps and trying to fix them is not going anywhere. So do you really see that the three standards for 5G which you made as a requirement is low latency, extreme broadband, and the third one you mentioned is IoT, as the driving the requirement, are the requirements going to be matched by standards or driven by open source? How do you see the three things?
The question is, the question is extended to me, or I must maintain my role as moderator? For sure, we have an expert of standard. I ask you to answer, but I can add something, being in the standards as well.
Please. Sure. I mean, it's probably not necessarily representing all the players in the standards, but definitely it's a very good question. So what is the role of standards going forward, especially as we talk about all these itinization of telecom network and so on. So I think it's also good to remember is still this radio and spectrum access plays a huge role in what we call telecom, especially in the wireless community. And as you mentioned, right, we're looking at these three areas for future growth, for application use cases. And another area that we have been working on also as a community is we already developed a very concrete set of requirements in terms of numbers, okay? In terms of the peak throughput. So we want to achieve 20 gigabits per second peak rate. We want to achieve 100 megabits per second of the edge rate, cell edge rate. So anywhere you go, you should be able to get that. We want to achieve 3 times spectral efficiency. We want to be able to support 1 million sort of devices in a 1 square kilometer area, and so on. There's also energy efficiency numbers. So these numbers are important sort of guidance for us to go forward, right? It's not something, I mean, definitely the software-defined network and NFV will play a key part of that. But we also need to look at radio side. We need to sort of go into the new frequency opportunities, as Vivek also mentioned earlier. Millimeter wave is one major area. For example, Samsung has a champion in. We've been investing a lot of effort on that, demonstrating the first capability in the world. We actually demonstrated this year, earlier last year actually, October 2014. We demonstrated more than 1 gigabit per second of speed at 110 kilometers per hour in Korea. And also there's a lot of work going on in the unlicensed band. You know, tapping into those spectrum assets that's not available today will be a key part of that. And for those type of radio spectrum access type of work, that will be a key part of the standardization and meeting the requirements that we set forward for 5G and meeting the vision of 5G, the use cases that we are looking forward to as well. So software is a big part of it, but let's not forget this radio is spectrum access.
If I can add a very simple point, is that I think that even if we innovate, any innovation must take into account the history. So honestly, I think that the success story of the mobile, so if mobile is a technology that is so widespread in the world, because we define some rules in terms of interoperability of the equipment. Without and interoperability is defined in the standardization law. So the history of mobile teach us that if you don't define rules that can work all over the world, the mobile can't work, because I want to use my phone here when I'm in the US, when I'm in China, when I'm here. I want to have a possibility of choosing an OEM or another OEM or whatever. I don't want it to be linked to a single provider, because competition is important. To have competition, to have the mobile work, if we don't have standard, there is no chance. Of course. And so I want to decouple the concept of having open source without not having standard. We can have open source solution and we can have standard. Of course, standards are important in some area, less probably in other. So I don't think that we have to standardize everything till the application layer. But for sure, standard is something that declares the success of this wonderful technology that we have in our pocket. I don't know.
Yeah, so
there's another question.
That's actually a good segue to my question. And this is a bit of a challenge maybe to Steve on his earlier comment about not having the different Gs, but just a network. And to Charlie's point, the ITU has defined essentially 3 different vectors of 5G. So essentially there'll be 5G-A, which the higher bandwidth, 5G-B, the IoT, and 5G-C, which is the low latency. So today, when you have something certified and compliant, you know it's compliant to a standard. Now, with 5G, you'll have 3 different design targets, and then theoretically 3 different conformance targets, and essentially 3 different standards. It seems to me that would create confusion and interoperability issues. So if I have my 20 gigabit per second thing I have here, they go somewhere else and I try to use it for low latency or whatever, it's not the same thing. So how do you address this marketing and perception issue, 5G?
Well, we already have multi-radio technology in our handsets, right? I mean, we're going to have 802.11, B, G, N, AC, some will have AD, some will have, WiGig, we've got LTE, I've got 3G, I've got 2G, so the ability to put multiple basebands in silicon, I mean, Moore's Law makes that free, right? I mean, I'm not saying it's easy, right? You have thousands of engineers in Intel that are doing that work, but you get to leverage that worldwide. The challenge is always, putting in more and more radio technologies. And again, think about just 6 or 7 years ago before we had global phones, right? You buy a phone, only this one band would work everywhere. We're shrinking them, it's getting easier. The way I view it, as long as I've got a few bands that work globally, I can actually do some stuff that's very specific to my country, as long as the costs are low enough, right? And again, the supply chain, I mean, if I wanted to open up TV white space in one country and have it in handsets, the cost is not that out of reach as you look out a few years, right? I mean, it's just, the marginal cost is pretty low. So I think you want some global standards, but you're gonna have some localized things. As long as you can communicate everywhere, that's fine. I think it's gonna open up more innovation, especially as you have more software-defined stuff. I mean, there's handset level software-defined radio just around the border, 100 milliwatt transceivers. That changes, that allows you to unlock a lot of orphan spectrum too.
Yeah, so I'll probably give you a simple analogy. So where I see how what we're doing is building this global standards and global communication platform. It's almost like building a highway. So when you build a highway, you want to serve all these different entities, right? There's hospitals, there's schools, there's residential areas, government, and everything. Everybody have slightly different requirements. But it does not mean that you have to build a road for each of them. You build a common infrastructure, and you try to make it robust enough so that everybody can still share at the end of the day. So it's kind of like what we're doing in the communication area. 5G will be a network that will be able to accommodate different needs, but doesn't mean every user, every device will actually need all these 3 things, like 20 gig per second or some millisecond latency and all that. So for some of them, they will use one set of criteria, the others will need another set of criteria. In some sense, this is what we're doing already today, even in LTE. We have category 0, category N, for example, especially for low price. machine type of applications. Then we have category 1, 2, 3, 4, and 5 for more high-speed broadband kind of applications. So that's how we typically run things around.
And even within that, NVLT, CVLT, several standards are all there. So we're already doing that today.
Yes, I think that this is really the strong challenge of 5G, having a single technologies that, like a chameleon, can of course adapt itself to the different business needs, to the different opportunities. That's why multi-RAT is mandatory. But I would like to stress that 5G is one, can have multi-RAT, can have even, there is a discussion that we did, sliced solution, simple sliced solution for the core, based like software routine that can be used and adapted for the needs of the specific technology. So this should be the great revolution with respect of the past, according to the people that are working around this.
And dynamic provisioning.
And dynamic provisioning, yes, dynamic provisioning and customer and service awareness. This is something that is very important.
Actually, I would take your argument to one level further, not only in the core, but also in the physical layer, map layer. We want to provide a way to really slice the network, down all the way down to the physical layer.
Is there time for one more question? A quick one, okay. Because I see here a lot of time, but I have a look at the watch and I think we are out of time. Okay, last question.
I'll try and make it quick. I don't know how quick the answer will be. So container-based technologies, they're getting more and more important for 5G. I mean, AT&T's statement about 95% virtualization by 2020 is well known. More recently, they said they'll be looking more and more into container-based technologies. So my question to you guys, primarily the operators, do you guys still foresee the importance of Nano going forward, say 2018, 2020? Or do you guys think that carriers will be migrating more and more to IP-based containerization technologies like Kubernetes, Swarm, etc.? Thank you.
Question to me or
operators or
I'm sorry, it's open to all.
No, okay, it's open to all. Okay. Now, honestly, we think that is a technology that have some step even before the 2020. But honestly, I think taking into account even the roadmap inside the standardization, I honestly think that the year of the first commercial deployment should be 2020. I know that there are, but I leave the word to South Korea, and because there is some push to have in 2018. Honestly, I have some doubt. I see that to have a mature technology in the commercial point of view, we need at least 5 years starting from now. In Europe, we don't have so strong push because we have to make money from LTE and LTE advanced. But honestly, independently on this, I think that being so revolutionary, the technology, according to me, is very difficult to have before. And we have to take into account that some spectrum for, let me say, above of the higher frequency will be delivered by WRC in 2019. So I don't know if you want to add something.
Yeah, sure. I think you mentioned very well. I mean, 5G is a journey. It's not a single event that will be defined by a single launch or something. I think there will be multiple milestones that going forward. A few we can see, right? Definitely, the 2020 is a very important milestone, especially with the Tokyo Summer Olympics being more of the flagship kind of event demonstrating the 5G capability and commercialization from standardization efforts and so on. But also before that, we also happy to announce in 2018 in South Korea there will be a Winter Olympics. So it's kind of interesting how the sports events are linked to these telecom or drive the telecom advancement. But there, our goal is to have so-called pre-commercial large-scale trials. So that will be a very, very important milestone also. So we will use that opportunity to demonstrate that this type of pre-commercial 5G millimeter wave technology is ready for prime time by giving them to the athletes and visitors alike. But then the commercial trial, I think there's also growing consensus will be more like 2020.
Okay, so I think that we are out of time, but I think that the discussion was very lively. Thanks for the questions, thanks from the panelists. And we have to work all together for having this new technology ready. And there are a lot of opportunity for startup, new technology players and whatever to deliver their technology in order to make 5G a success story. So thank you to the audience. To the panel.